Hey YouTube, JP Dillon. We're going to do something a little different today, and I'm going to review a product. And I sell a lot of these through the store I work for, and they're very popular for people that just want a basic get it done thing. And this is a Lepai LP-269fs. Claims to be a 4-channel 45x4, which can't possibly be, but we'll see what it really does. It's basically a mini receiver. It reads your SD cards, USB stick, iPod, also has Bluetooth for integrating with your phone. Also comes with a little chintzy remote. And it's, it's nothing great, but if you just need sound for your office desktop or whatever, it's not a bad thing. It sounds okay. But the purpose of this is to show what it really does power-wise, and whether it's really 4 discrete channels or whether it's just kind of piggybacked on top of each other. So what I've got is we're going to plug in my signal generator. I'm going to hook it up to a load bank. We're going to see if the two channels are tied together, because they do have 4 speaker jacks here. It says 12 volts, 3 amps. 3 amps, 12 volts, that's what, 360 watts? Or no, 360, yeah, 36 watts. 36 watts of power. So that right away, if you divide that by 4, that would technically be 9 watts a channel if it was 100% efficient, which it's not. So let's go ahead and plug it in and see what it really does with its own power supply, which is a 3 amp switch mode power supply. I don't really foresee this doing much. We can also see about hooking it up to a fatter power supply and see if that does something, but let's see what it does on its own. Alright, so before we proceed, what I've done here is I'm measuring the resistance between the first set of speakers and the second set, and it's literally tied together. So this is not 4 discrete channels as they purport. This is just a 2-channel amplifier that they run into 2 sets of speaker jacks. So not 45x4. Let's see what it really does. Okay, it's all hooked up. Hi. Alright, let's go to auxiliary and let's crank it up. We're putting in a standard line level signal right now. I lost a channel there for a second. That was interesting. So at a line level signal, it doesn't get very loud. That's at maximum volume. So let's put in a bigger than line level signal. Okay, so that's not too much difference except for your clipping. It's a very small output, maybe a couple watts, I think. Let's just look and see when the clipping disappears, right about there. And let's check our frequency response. Let's put these at the midpoint position and see if that frequency response is linear, starting at, let's see, that's 70 hertz. It starts to roll off below 50. Okay. 200, 300, 400, 500, 600, 700. There's a kilohertz. It's got a little tiny hump in the 500 range. And it starts to get a little bit non-linear around the 3 kilohertz range. You can see that our amplitude has dropped off a little bit. That's 10K. Can you hear that thing singing? Mike's probably can't pick it up. I can hear it singing. 10K. So after 20K it rolls off anyways. Not really important, since most people can't hear 20K. I don't think anybody can hear 20K. Alright, so this is our clip point. And it's pretty linear, maybe a little bit of non-linearity. But let's see what really it's putting out. And since these are parallel, I can just hook my meter up to the second set. Alright, so this is really what it's really doing per channel. About 7.5 volts RMS. Which, goodness, it's maybe 7.5, 8 watts tops. Yeah, about 7 3/4 watts. Not very much. That's into 8 ohms, and that's at the clipping point. So a total of 16 watts. God, that's less than 50% efficient. That's if it's really using 3 amps of current. Yeah, that's pretty sad. That's even worse than the little tiny one. The little tiny one was at least 8 watts a channel from what I remember. Interesting. Alright, so now what I've done is I've hooked it up to the big boy 12 volt supply here. And that has up to 10 amps of current. Whereas I guess this one was starting to sag a little bit because that got us a little more power. We're now up to 8.46 volts RMS, which just pushes it over the 8 1/4 watt per channel, continuous. But still, yeah, less than 50% efficient. So I guess it's not a Class D, even though it says it is, or if it is a Class D, it's terribly inefficient. Now, I suppose what we can do is maybe I'll try it on a 4 ohm load and see what a 4 ohm load does. Well, surprisingly, on a 4 ohm load, the voltage only drops a little tiny bit. Now granted, I'm on this really awesome power supply. Let's switch over to the stock power supply, because that would be 16 watts per channel into 4 ohms, which isn't too bad. Let's try the original power supply and see what that does. And now we're clipping like crazy. Yeah. Alright, so we make the clipping go away. Then it's somewhat less. Then it's about 12 watts per channel into 4 ohms. So this is kind of a dinky power supply. Whew, that's getting toasty. Doesn't like that 4 ohm load. So definitely you need something with a little more oomph than the stock power supply. Maybe a 5 amp would do. Because with this one, you can definitely run it up and you can squeeze 16 watts out of it per channel. So that's 32 watts. Probably not less than 4 ohms. This is starting to get a little warm, but not unreasonable. So yeah. So definitely not purporting what it's supposed to be. 45 times 4, maybe into 2 ohms, and that certainly wouldn't last very long. But it's a fairly clean linear amplifier for being a cheap thing. My gripe about it is the stock power supply. You could probably squeeze an extra watt or two out of it if you had a bigger power supply. However, if you've got efficient speakers, that really doesn't matter. Also notice the voltage fluctuating a bit here. I don't know if that's a function of like an auto protect thing or what. It kind of keeps going down. Look at that. And that's an input signal thing, because I can turn the signal up and it gets there. So maybe it's got an internal failure, but I'm not going to troubleshoot it. But yeah, for a little cheap thing, it's cool. Desktop amplifier, something like that. So thought you guys would just really like to know what's going on with it, so you can get an idea as to what you're buying. These things are cheap on Parts Express. They're like 40 bucks. And they don't sound bad, but you definitely will want efficient speakers. Now, if we turn up the sensitivity on the scope, here's what you're going to see. That's the suck thing about this. It's not high fidelity. Those are switch mode transients. So I guess it is a digital amplifier, because nominally those wouldn't show up in a Class AB unless something was horribly wrong. So it's not going to be super clean. That's with the volume all the way up. If you turn the volume down, it gets a little better, but there's still lots of digital hash there. Most of it you probably won't hear other than just hiss. But yeah, cheap amplifier. If you just need it for your desktop or your garage, it's probably fine. It does not have a headphone amp. It'll do 4 ohm loads, obviously. And the fact that the output actually doubles without the power supply, or my power supply, sagging suggests that it's pretty stable. Their switch mode power supply thing is weak, and you can squeeze another watt or two out of it with something more than that. But there you go. Hope you guys enjoyed watching the little video, and more stuff to come later.